All right, welcome back. So here's an example that we're going to work out. So notice a couple of clues. When you see a radical 1 minus y squared, you recognize that's part of a circle. It's not really a clue, but I suppose it's a bit of a clue. X squared plus y squared, when you switch to polar, that's just going to become r squared. This part right here is just going to become r squared. So let's begin by sketching our region. That makes the switch to polar easy. Strongly encourage you, don't try to just do this in your head. So what's happening? Well, we have x is going from 0 to x equals that radical. X equals 1 minus y squared, but that's the same as x squared plus y squared equals 1. So again, we're on the right side of the unit circle. Y is going from 0 to 1, and so the region that we're integrating over is just this guy. I'm not going to take the time to draw this too neatly. That's our region of integration. In terms of polar, it's pretty easy. What's theta doing? Theta is going from 0, and we're swinging up to pi halves. R is starting at length 0, and then you just want to extend out to length 1. So we're ready to make the switch now. So this is the same thing as the double integral. Let's do the bounds first. I'm always going to write this dr d theta. So r goes from 0 to 1. Theta goes from 0 to pi halves. You can actually do the substitution x equals r cosine theta and y equals r sine theta, but you already know that when you do that, x squared plus y squared just becomes r squared. So this is just an r squared. The key is don't forget that dx dy doesn't just become dr d theta, it's r dr d theta. And now this is equal to the integral from 0 to 1, 0 to pi halves of just r cubed dr d theta. At this point, you don't need to do anything else other than just standard integration. At this point, we've just rewritten this integral in terms of r's and theta. You just treat these exactly like you would any other variables. You just integrate. I'm not going to work it out, but you get r to the fourth, you plug in. Actually, you can break this one up because it's just r cubed. So you're going to have, what, just a pi halves sitting out there times r to the fourth over 4, evaluated from 0 to 1, which is going to be pi over 8. So I did work it out. So that's that one. All right, I'll stop this example, and then I'm going to post a couple other examples as well. I'll post these one by one so the videos aren't too huge.